All right, so here's the continuation of the lesson, the second part about partial fraction decomposition. First, let's look at another issue that might come up, and then we're going to look at a whole different type of method other than the corresponding coefficients method. So the next problem that could come up, we've dealt with a repeated linear factor. Let's take a look at what happens if we have a factor in the denominator that's quadratic and we cannot reduce it to linear. So we have an irreducible quadratic factor. Let's take a look at an example. Suppose I have the following expression, x squared plus 4x plus 1 over x cubed minus x squared plus x minus 1. And I want to break this down. Well, I need to factor the denominator to see how it's going to break down. That might be a whole issue right there. We should be able to see this one pretty clearly and easily. Let me take a moment on this one. When factoring, it's got 4 terms in it, so I'm thinking grouping. If I group the first two together, x cubed minus x squared plus x minus 1, I can factor out an x squared here, and I get x minus 1. Can't factor anything out of that. But the x minus 1s I can factor out, x minus 1, and I'm left with x squared plus 1. So this now becomes x squared plus 4x plus 1 over x minus 1, x squared plus 1. The x squared plus 1, there's the problem. This is an irreducible quadratic factor. So what's going to happen now? Well, I'm going to break it up into something over x minus 1, and I can't reduce that. Let me make a note about this. This is an irreducible quadratic factor. That's the problem that's happening here, an irreducible quadratic factor. So I can't break that up anymore. So I'm going to have the x squared plus 1 down here. Now notice that up until now, these have all been constants, constant over a linear. The numerator is always going to be 1 degree less than the denominator. But now I've got a quadratic denominator. So it's not going to be a number up here. It's going to be something times x plus a constant. So we're going to write it as bx plus c. So I'm going to have something over x minus 1, and then bx plus c, a linear over this quadratic, a first degree over the second degree. So I've got 3 variables that I need to find, the a, the b, and the c. And as you can imagine, our first step here is going to be multiplying by the common denominator to make all of the denominators go away. So I'm going to take this whole equation, and I'm going to multiply it by the x minus 1 and the x squared plus 1, multiply it in. And when I do, I'm going to get just the numerator here, x squared plus 4x plus 1 equals a times, let's see, the x minus 1s will cancel, and I'm going to get left with x squared plus 1 plus, here, the x squared plus 1s will cancel, and I'm going to get left with bx plus c times x minus 1. And we know we have to break this up and match it. We're going to group all the x squareds together, and whatever the coefficient is, match that to 1. Group all the x's together, whatever that is, that's 4. And all the constants together are going to become 1. All right, so here's the algebra. X squared plus 4x plus 1 equals ax squared plus a. If I FOIL this out, bx squared minus bx plus cx minus c. Let's group everything together on that right-hand side now. ax squared plus bx squared minus bx plus cx plus a minus c. Let's factor so we can see what my coefficients are going to be. X squared plus 4x plus 1 equals a plus b, that's the coefficient of my x squared, plus negative b plus c, that's the coefficient of my x, plus a minus c, that's going to be my constant. So matching it up, 1 and a plus b. 4 and negative b plus c. 1 and a minus c. Write the little system down, and I'm going to have 1 equals a plus b. 4 equals negative b plus c. And 1 equals a minus c. So here's my little system. This is the system of equations that I now need to solve. And as I look at this, it's 3 equations with 3 variables. I'm going to have to combine them and solve it. Again, I hope that the solving the system isn't the hardest part about these problems. Let's take a look at solving this system now. I'm going to take these 2 equations and add them together. 1 equals a minus c, and 4 equals negative b plus c. If I add those together, I get 5 equals a minus b. I'm adding the equations together. The c's are going to cancel each other out, and I'm going to have a minus b. And then this, my first equation, bring that down. 1 equals a plus b. Combine these together, and I get 6 equals 2a. A equals 3. So we're well under our way to solving this little system here. Now I need to solve for b. I could use any one of these equations, really. If I use this first equation here, 1 equals a plus b, 1 equals 3 plus b, b equals negative 2. So I've got my a, I've got my b, I need to find c. I can use this equation right here. 4 equals negative b plus c. 4 equals negative 2 plus c. Oh, I'm running out of room, sorry about that. That's a positive 2 there. Subtract 2 from both sides. 2 equals c. So now I can substitute these back onto my original partial fraction decomposition. Here it is. And I know that x squared plus 4x plus 1 over x minus 1, x squared plus 1 decomposes, breaks down to my a value, which is 3 over x minus 1 plus bx plus c. My b was a negative 2, so negative 2x. My c was a 2 over the irreducible quadratic factor of x squared plus 1. So there it is, kind of broken down into the 2 different parts, partial fraction decomposition. All right, so for the last part, what I'd like to do is I'd like to look at another problem, not so bad, but this time I want to introduce a new method, a different way of solving it. So let's consider the expression 7x minus 7 over x squared minus 3x minus 10. And I want to decompose that. I want to break it down, partial fraction decomposition. Well, still have to factor and deal with the factoring here. So it's going to be 7x minus 7 over, this factors nicely to x minus 5, x plus 2. So it's going to break down to something over x minus 5 plus something else over x plus 2. So this other method starts the same way, and indeed the next step is going to be the same as well. I'm going to get rid of all of the denominators by multiplying the whole thing by x minus 5 and x plus 2. Multiply here and there and there. Make all of the denominators go away. And then I've got 7x minus 7 equals a times x plus 2 and b times x minus 5. Now this is where the 2 methods are going to change. The last time we did the matching coefficients. I would multiply the a, multiply the b, get all the x's together, set that equal to 7, the coefficient, get the constants together, set that equal to negative 7, and I would solve the little system that ensues. But this time what we're going to do is something called the convenient number method. So it's just a different method for finding a partial fraction decomposition. And in the convenient number method, I'm going to do exactly what the title implies. I'm going to pick a convenient number. What's a convenient number and why is it convenient? Well, look at this here, this x plus 2. If I pick x equals to negative 2, then I'll be able to plug in x's here and here and here, and when I plug it in here, the a's will go away, and I'll be able to solve for b. So the first convenient number I'm going to look at is, let's see what happens when x equals negative 2. If I plug negative 2 in, I'm going to have 7 times negative 2 minus 7 equals a times negative 2 plus 2 plus b times negative 2 minus 5. 7 times negative 2, negative 14 minus 7 equals a times 0 minus 7b. Negative 2 and negative 5 is negative 7 times b. So the a's disappear here, and I get negative 21 equals negative 7b, divide both sides, and I get b is equal to 3. So now I want to find a, and I could plug a back in there, but I noticed that there's another convenient number that I could use when x equals 5. So let's see what happens when x equals 5. So now I'm going to plug 5 in here for x's, realizing that it'll make b go away, and I'll be able to solve for the a's. 7 times 5 minus 7 equals a times 5 plus 2 plus b times 5 minus 5. I get 35 minus 7 equals 7a plus b times 0, which means that's going to disappear. I'm going to get 28 equals 7a. A is equal to 4. So looking back, so I found my a and my b and my partial fractions. So looking back at the original problem, I now know that 7x minus 7 over x minus 5 times x plus 2 breaks down to my a value, which was 4 over x minus 5, plus my b value, which is 3 over x plus 2. There's the partial fraction decomposition. So it's just a different method, a different way of solving it. And it doesn't always work. You know, sometimes you could have, if you pick a number, too many things disappear or not enough things disappear. The system way is usually a little bit longer, and sometimes the systems can be a little bit awkward, but pretty much it's always going to work. This will only work in some circumstances. Now, when it comes time for the test, you really can use either method, whatever method you think works and applies. If this one confuses you a little bit, then just ignore it, forget about it, and just do everything by matching coefficients and doing the little system. But if this one jumps out at you as a nice way of solving something, then feel free to use it. Go ahead and use it. All right, ladies and gentlemen, that brings us to the end of Chapter 5. Gosh, I'm sorry I haven't been there for all of Chapter 5. What happens next? So tomorrow will be the Chapter 5 review. And I have a little game, a little in-class activity to work on it and to do things. By now, you know that my reviews are very much like my test. If you can do all the problems tomorrow on the review, you'll be fine on the test. And of course, that means the test is coming up here as well. The review is tomorrow on the 25th. The test will be on the 26th. The test will be on Wednesday, 26th. Be a non-calculator part and a calculator part. As soon as you come in, get ready for it. Remember, cell phones, turn them off in the backpack. Everything else in the backpack. Leave your computers, calculators out. We'll start with the non-calculator part. Hand them out and then collect those. And just like with the homework, ladies and gentlemen, I will be grading all the tests. I'm going to grade all the homework and all of the tests. And even though I won't be there, you'll still have the opportunity to do test corrections a little bit later for a better grade. I'm certainly hoping to be returning to you soon, although we'll be starting Chapter 6 in a couple of days, and I will be doing at least the first few lessons from Chapter 6 with videos as well. Remember, you can also catch and review these again on the YouTube, the Arizona Mathman channel. And if you've got any questions, put them in the comments section, including the review. Tomorrow, if you've got any questions you can't figure out, you can add them to the question section of this lesson, and I will try to answer them as quick as possible before your tests. If not, I'll be talking to you after the test when we start Chapter 6. Good luck, ladies and gentlemen.